Hello everyone, Assalamualaikum warahmatullahi wabarakatuh. Welcome back again to my lecture video. Okay, today we are going to talk about a new topic, which is friction. Okay, so when we say friction, there are two types of friction, which is wet friction and also dry friction. Okay, wet friction is something that we put a liquid or lubricant between two surfaces, so that we want to reduce the friction. I suppose everyone know what is friction. Okay, and for dry friction means that we don't have any lubricant in the middle of the surface. So in this topic here, we are going to be focusing on dry friction only. Okay, so what we are going to do, or what we are going to calculate, we are going to calculate, let's say we have a box on a floor, on the floor, and we want to move the box. So what is the force that is needed to move the box? That is one of the example what we are going to calculate or determine. Okay, so because I mentioned about the box, so let's look at a box on a floor. Okay, let's look at this box here. Okay, we want to move this box to the to the right side. So let's draw the free body diagram of this box. Okay everyone, this box here has a weight. Of course lah. So means that we will have a weight in the middle of the box, and then if you look here, the box made contact with the floor. Okay, this surface here. So this one here, because it made contact and we want to make it free, means that we need to have a reaction force. Okay, so what is the reaction force for friction here? For friction here, we will have this one, a normal force. Okay, normal force here must be 90 degree, compulsory 90 degree with the surface. The next one is this one. F. What is the difference between this F? Okay, this F and this F. So this F here is the friction force. Okay, this friction force here must be perpendicular to the normal force. Again, normal force must be 90 degree with the surface, and the friction force must be perpendicular to the normal force. If you look closely, it is just like this is the reaction in Y and this is the reaction in X direction. Some kind of that. Okay, so the relation between F and N is this one. F is equals to mu N. So this mu here, will be differ based on the type of the surface. And this mu also, we have two types of mu. So what is mu? So mu here is actually coefficient of friction. Okay, so as I mentioned earlier, we have two types of coefficient of friction. The first one is coefficient of static friction. The second one is coefficient of kinetic friction. Okay, so for coefficient of static friction, the symbol is mu S, and for kinetic friction is mu K. So what is the difference between this one and this one? Which one to use? Okay, when the object has no movement, means that it is stay in its place, so we use mu S. When the object is moving in a constant velocity, so that is when we use mu K. Okay, usually the question will provide you with the value of mu S and mu K. So you need to choose which one to use. Okay, and the relation between mu S and mu K is this one. Mu S is always larger than mu K. If you look at this friction here, so if mu S is larger than mu K, so based on your experience pushing a box, of course everyone must have experience pushing something. when we want to push it at first, we feel we need to put a lot of force, okay, to push it. But when the object is already moving, so we can feel that we apply slightly a lower force to make it move. So that is why mu s is actually larger than mu k. Okay, when I say move, actually there are two types of movement. Okay, what are those? This one, okay, sliding and also tipping. Okay, so it can be two situations. Sliding means that sliding lah, sliding, and tipping is tipping. Okay, when we apply a force, it can be sliding or tipping. So what is the difference on the free body diagram of sliding and tipping? When we want to slide something, sliding, the normal force, the position of the normal force must be this one, below the surface here. Okay, below here. Okay, means that what I draw here, this one here is actually sliding. So this is the situation when it is sliding. So what is the situation when it is tipping? Okay, let's draw the free body diagram of tipping. So this is the free body diagram when it is tipping. Can you see the difference? Okay. So here, as you can see here, the position of the normal force is actually at the tip of the object. Why? Refer back to this picture here. Okay, this animation here. As you can see, when we want to tip something, okay, the area, okay, so this is the only area that made contact with the surface. So means that the location of the normal force must be at this one, okay, at the tip, bottom tip of the object, this one. Okay, so this is the basic of friction. So in the next lecture, I will show you on how to calculate the force that is needed to slide or to tip the object. Okay, so please stay tuned. See you again in the next lecture. Bye bye.